So I'm sorry, I had the smartboard pulled up, I had my camera on the tripod, and it just stopped recording in the middle. So here is my short and sweet version, because we're going to go over this more tomorrow. So today we talked about estimating quotients. Remember, a quotient is a division, the answer to a division problem. So I'm just going to write division answer. So we're estimating quotients for greater dividends. Remember, a dividend is the number being divided. And of course, when we estimate, we are making numbers easier to work with, but our whole point of estimating is to make sure that we get an answer that is close to our exact answer. So far, when we have learned about estimating or rounding, so far we've talked about sums, differences, and products. Now, with all of these, we have used our typical 5 or more, raise the score, 4 or less, let it rest, right? Well, when we estimate quotients, it's a little different. So I have quotients over here. Now, we still got to keep it in the back of our mind, 5 or more, raise the score, yes. But with quotients, we're going to use something called compatible numbers. Now, compatible numbers are numbers that get along with each other, because that's what compatible means. They can work together, right? So let's take a look at how we use these compatible numbers. Now, I think this is a much easier way to estimate because there's not as many rules. You just want to make sure you get as close to my exact number as possible. So let's look at this. So this number 1 is going to kind of break down our steps for us. So whenever we estimate our quotient with compatible numbers, our first step is to think of the multiples of our divisor, which is 8. So this first step, we're thinking of our multiples of 8. So in our head, we're going through 8, 16, 24, 32, 40, 48, 56, and so on. So we're going all the way to, 8 times 12. So that's what this wants to get you to thinking about now. So write out your multiples. So 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6. And we would keep going and just know that we could possibly use any of those multiples. So estimating with compatible numbers, look at the divisor first and think about the multiples of that divisor. So I'm thinking about these skip counting numbers, right? Now, after I think about those skip counting numbers, I'm going to come and underline always my first 2 digits right here. So I'm looking at my first 2 digits only. So I can look at this as a 15 right now. So now I'm thinking about my multiples of 8. And the whole purpose of that is I want to get a multiple that is extremely close to this number right here, 15. Not the whole thing, just my first 2 numbers, 15. So what is a multiple of 8 that is really, really, really close to 15? Well, that multiple is 16 because it's only 1 away. Now, it doesn't matter if I go over or under 15. All that matters, since I'm estimating, is that I get it as close as I can to it. So 16 is the closest because if I pick 24, that is going to be from my 15, that's going to be 9 away from it. So that's way too far. So I only need to pick my 16 because it is 1 away from it. So I change my 15 to a 16, and then everything behind it, because I'm estimating, everything behind it turns to zeros. So now, that was my second step, underline my first 2 digits. Now, this was kind of part of the second step, but I'm thinking about which multiple of 8 is closest to 15. So I picked 16, remember. I turned my remaining numbers to zeros. So let's look right here. Kind of skip this one for now. Look down here. This is my new problem right here. This is where I've estimated. So this is where I'm actually going to start solving. This falls back after I've rounded, after I've estimated. This goes back to our lesson from yesterday. So box your basic fact and say, what times 8 is 16? Well, that's 2. How many zeros do I have out there? 2. So I'll put 2 down. So 1,561 divided by 8 is about 200. Now, they did add in this little step right here, and this is really what's going on in your head whenever you pick 16. We picked 16 because it was really close to 15, right? The reason why I picked 16 is I know that 2 times 8 is 16. And if I'm thinking of it as hundreds, it'd be 1,600. So don't worry too much about that part. It's just kind of a deeper part. So let's practice this. So look at number 2. So remember my first step, I'm going to think about my multiples of 9. So you don't have to write them out, but I'm going to write them out just so you can see. Think about your multiples of 9. 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5. Try not to write what I'm saying. 9 times 6, 9 times 7, 9 times 8, 9 times 9, 9 times 10, 9 times 11, and then 9 times 12. So I'm thinking about all of my multiples of 9, right? I underline my first 2 digits and I say, okay, what's a multiple of 9 that's really close to 46? All right, so in your head, now we don't have time to write this out. That's why we wanted to learn those multiplication facts really good. In your head, you want to pick the closest one to 46. Well, my closest one to 46 is going to be 45 because it's only 1 away. And then since I'm estimating my other numbers, which happens to be this one, it's going to turn into a 0. So now I'm back to my lesson from yesterday. What times 9 is 45? 5. How many extra zeros? 1. So 461 divided by 9 is about 50. All right, try another one. Think of your multiples of 6. Underline my first 2 numbers. Now, I'm not going to write out these multiples because we got to know them, right? Think of your multiples of 6. So in your head, you're thinking 6, 12, 18, 24. Okay, there we go. 24 is really close to 23. Everything behind it turns to zeros. And I'm back to my lesson from yesterday. What times 6 is 24? 4. How many zeros are out there? 2. So, 2,356 divided by 6 is about 400. All right? Try this one on your own. Pause it maybe, and then see if you get it right. So, think about your multiples of 9, which luckily I have those right out up here. Underline your first 2 digits. What's a multiple of 9 that's really close to 53? 54. So I change it to 54. Everything behind it turns to zeros, and I'm back to yesterday's lesson. What times 9 is 54? 6. How many zeros? 2. All right, now I did do an extra example where I showed everybody that you could possibly, so if I have 491 divided by 7, and I underline the first 2 digits, well, I think about my multiples of 7, and I can actually pick a multiple that falls right on those 2 numbers, because I would pick 49, and then that would change to a 0. And back to yesterday's lesson, what times 7 is 49? 7, with a 0 on the end. I also showed what happens when I get a number that's kind of in between. Like if, oh, well, no, sorry, I didn't mean to put 16. I should have put something else. Let me write that out real quick. Let me do a bigger number here. So let me do 1,700, 18. All right. So if I underline 17 and I think about my multiples of 2, well, my multiples of 2 can cause a problem because I know that 2 times 8 is 16 and 2 times 9 is 18. And both of those numbers are 1 digit away, 16, 17, then 17, 18. So they're equally close. So whenever that happens, I need to look right here behind it and see what's going on. Since I have a 1 right there that's behind it, I really probably want to pick, since it's a 1 and it's lower than 5 or more raise the score, 4 or less let it rest, I really think that 16 is going to be the better estimate because of that number being lower. So I'd change that to a 16, turn those into zeros, and do my lesson from yesterday. What times 2 is 16? 8. And then put my 2 zeros. And then lastly, you will have problems like this that may give you a larger number out in front. Now, the greatest multiple that I know of 3 is 3 times 12, which is 36, right? Look at that. That's 69. That's really big. So let's break this down a little bit. My divisor is 3, so let's think about 6 first. Will 3 times anything give me 6? Yes. So I want to keep that a 6 because I know I can divide and get that. Now let's look at just the 9. Will 3 times anything give me 9? Yes. So I want to keep that a 9. And then for everything else, I'm just going to turn it into zeros. Now, I'm back to yesterday's lesson, but this is a really big number. So let's break it apart again for my answer. Look at your 6. What times 3 gives me 6? 2. So that goes in my first spot here. What times 3 gives me 9? 3. That goes in my second spot there. And then how many zeros are in the end? 2. So my answer is 2,300, or my estimate is 2,300. So I hope this has helped. If you get stuck on them, just do your best, but I do want you to try because we are going to go over this more tomorrow. You do need to do the whole thing and just be careful. Make sure you're underlining and I can see what you change those first 2 numbers to because that's going to help me help you. And then make sure down here you have 3 questions you got to answer. So make sure you answer all of them. Okay? Hope it helps.